Hi, welcome to Solving Science, episode number 4. We're trying to solve the universe and explain the universe using expanse tension theory based on anomalies and mysteries of science that are reported in the news. And today, exciting, dark stars, as reported by New Scientist, edition, the 14th of June, 2025, on page 16. So, dark stars. The James Webb Space Telescope has identified a very unusual type of very early universe star, occurring only a few million years after the Big Bang, where the standard model predicts they should really only appear at 200 or 300 million years after the Big Bang. So something's going a little bit wrong. They're extremely bright, they're extremely early, and they're giving signatures of helium and oxygen, which also indicates some atomic generation within these stars, which is again not predicted at this stage of the universe. So what's the current thinking? Well, dark stars made of self-annihilating dark matter. So remember, dark matter, we've been looking for it along with dark energy for over 50 years. We've spent about $50 billion looking for it. We haven't, of course, found a trace. But beyond dark matter, we've now created the idea of self-annihilating dark matter. I think we need a different explanation. So let's have a look. What can expanse tension theory throw at this phenomenon? Well, firstly, we're operating in the extreme dense regions of the very early universe. And in that universe, expanse tension theory proposes that the coupling between the expansion field and mass is uncoupled, which then reduces the effective expansion drag on overdense hydrogen helium clouds. That can permit a rapid collapse of these supermassive gas objects. It can also sustain them as giant luminous structures, explaining the brightness that we see in this star. The heating mechanism we see could be because of a transition from the high density to the low density outer regions, which can inject a tension energy, which again expanse tension theory predicts, and that can then maintain this brightness that we see, this luminosity, before nuclear ignition of the star. It would also predict the signatures of helium lines and oxygen signatures on the star. So, expanse tension theory with this particular dark star candidate predicts the collapse timescales could be shortened by a factor of up to 5, happening much earlier after the Big Bang, as seen. Star formation efficiency could rise by 50 to 80% versus the standard model, explaining why these star formations are happening much earlier in the early universe, triggered by this coupling modulation in expanse tension theory. So this particular star that's been observed, it could be a dark star made of dark energy and burning self-annihilating dark matter, or expanse tension theory posits that it's the first observational proof of a density-dependent universe driving star formation mechanism in a way consistent with quantum field theory. So again, another success for expanse tension theory. We're able to explain the anomaly in very simple terms that we see in this report. Again, an indication that expanse tension theory has a predictive ability to explain the universe that we see, again, across a very broad and wide spectrum of different cosmic phenomena. So thank you for watching. Please share this video with any scientists that you know who might be interested in trying to understand the universe further. And thank you. Bye-bye.